In the beginning, God said, "Let there be light." And the Big Bang happened, and there was light. Now, for some people, that light could be, what powers their homes, electricity. For some, it's nothing more than what ignites their cigars, their smoke. But for scientists and physicists, that light means a lot. In fact, in the turn of the 20th century, the beginning of the 1900s, one very renowned physicist called Max Planck found that this light is more than what ignites the cigar. Actually, this light is made up of packets. So think of it. A beam of light is continuous. It shines from whatever light source you have, be it a torchlight or the sun, and it goes continuously. There is no breakage. However, Planck found something really interesting. What he found is that light actually occurs in unit packets, which means the way you have a grain of rice pouring out from a bag and pouring out in bits, in seeds, unit by unit, light actually comes in units like that. And those units are called quanta. Now that is the birth of a new field of knowledge known as quantum mechanics, aka the crazy part of science. Now, why is quantum mechanics crazy?
So quantum mechanics is the study of the very small,
very tiny things. What you get if you slice an apple indefinitely, that small thing. Now, with modern technologies, we have found that you can actually break that small thing that you get if you slice an apple indefinitely, and you find smaller particles inside of it. So particles like electrons, like protons, like leptons, like quarks, and so on and so forth. But that is not the interesting part. The interesting part is, in reality, you cannot be in more than one place at a time. But once you get into the realm of quantum physics, that becomes very possible. As a matter of fact, in the quantum realm, you can be at work and be on your bed at the same time, even though you are not a ghost copper. In fact, there's a popular thought experiment known as the Schrodinger's cat experiment that predicts that it is possible in the quantum world for a cat to be both dead and alive at the same time. Now you can imagine what that would mean for a world like our own, if people can be dead and alive at the same time. If that is not enough craziness in itself, there's something else about quantum mechanics. Now think about this. Imagine you had two friends that had a very, very peculiar situation, and that is whenever one cries, the other laughs. If they are in a room, it is easy to tell why one is laughing and one is crying because they can see themselves. If one cries, one instantly starts laughing. And if one laughs, the other starts crying. They can see themselves. It's no big deal. But imagine taking them miles apart, keeping one in the western part of the world and one in the eastern part of the world, and having people watch them. And then you still observe that.
whenever one laughs, one cries.
And whenever one cries, one laughs. Then it becomes an interesting matter. It becomes something to investigate. That is common in quantum physics. In fact, it is the norm. It is the reality in quantum physics. It's come to be known as quantum entanglement. So quantum particles, those small particles, can be entangled in such a way that whenever something happens to one, the other one responds instantaneously, even though they are miles apart. Now that is crazy. That is technically magic. But unlike physicists, engineers are not interested in being Merlin. They realize that in the quantum space, there is a unique kind of particle that you don't have in the classical realm, which is the realm of the very big and the very large. We have been taught that computers work with bits, right? And they only occupy two states, ones or zeros. However, engineers realize that in the quantum realm, there is something called quantum bits that operate, and they can occupy 1 and 0 at the same time. Does this sound familiar? Yes. It suffices to say you can do all things through quantum mechanics that strengthens you. In fact, this became the birth of a modern paradigm of computing known as, drum rolls please, quantum computing.
The fact that all the secrets would be open to anybody with a quantum computer. Any teenager with a quantum computer would be able to tap into the crown jewel. You could break into a regular bank, but it would take a few thousand years to do that. With a quantum computer, you could do that with the flick of a dial.
You have nothing to worry about. But quantum computers actually have the potential to break the most sophisticated encryption standards we currently have in the world. But beyond breaking into your bank account, quantum computers are good for so much more. In fact, from protein folding to drug discovery to advanced artificial intelligence, quantum computers show a lot of promise in tackling some of the toughest problems in the world. Why are quantum computers more suitable than classical computers to solve this problem? The reason is simple. Remember what we said about classical bits? They can only occupy one state at a time, either one or zero. So if you pose a problem to a classical computer, it tries one solution at a time. If it fails, it iterates into another solution. Computers can be fast, but for really advanced problems, no matter how fast they are, they will take so many years, sometimes millions of years, to solve those problems. However, quantum computers can occupy so many states at the same time. What that means in layman terms is they are able to try out so many possible solutions until they get the right solution. So, what could take a classical computer hundreds of years to solve could take a quantum computer a few minutes to an hour to solve. And this has been experimentally verified. So you can imagine the power wielded by a quantum computer, and your bank accounts are still there. Well, like I said, you have nothing to worry about, especially if you like and subscribe to this channel. My name is Abu Dozier, a science junkie and a guardian of the galaxy. Hello.